All right, I apologize. Mr. Palmer called me. He's coming home from baseball practice with Kenny. But I noticed the video was getting long anyways. So let me go ahead and do the range, and then I have one last example for you, and we'll be done with this lesson. So remember, the range are my Y values, and I'm simply going to scan any graph that I'm given to include all the values on the graph moving from the bottom to the top, because that's how my Y axis moves. So looking at this first one, number 5, there's my Y axis from bottom to top. And so I'm just going to scan it, and I'm going to pull this vertex point over, and it looks like it's just going to go right over to the origin, to 0, 0. And I can flatten this line out and make it straight. So it looks like from here it's going to go straight down and never stop, because I see those I see the arrows. And if I pull this one over and make it flat, it's going to simply go straight up and once again never stop. So what number's at the bottom? Negative infinity. And what number's at the top? Positive infinity. So if I were going to write this in interval notation, I would simply write negative infinity, because it's at the bottom, because remember I'm reading bottom to top, comma, positive infinity. And from the first lesson, infinity always gets parentheses. And once again, just like with the domain with my x values, when it's in negative to positive infinity, for set builder, I can simply write all real numbers. Okay, I don't have to put anything else. All right, I'm going to see that circle again. So on that circle, I want to look for y. I want to look for the y-axis. So now I'm reading it from bottom to top. Well, the circle looks like it starts right here. And remember, my circle has no openings in it. There's no holes in it. There's no open circles. I would obviously see them. And it looks like it ends right there. So I pull it over to the axis. There is my range. So I'm going to count negative 1, 2, negative 2, positive 1, 2, 3, 4. I always read from bottom to top. So negative 2, comma, positive 4. No opening, so bracket, bracket. I see a number and a number. So I'm going to go ahead and start my set builder, y, such that I changed my variable to the letter y because I'm doing range now. I would continue to do x only if I'm still talking about domain. Now remember, this is where I told you you could use your less than x, less than, but you want to make sure that you change your x to a y. You're going to see it change to y. You put the first number first. You put the second number second. You close it up. You come back and say, oh, there was a bracket. It's closed or equal. Oh, there was a bracket. It's closed or equal. And you're done. Okay. This one. I'm going to go ahead and take a look at the y-axis. And this one's a little bit different. So what I would do is I would pull this over and put it right here. And I'm kind of thinking about that line that looks like this, and I'm going to swing it down straight. So it's simply going to come down like this. This number is, of course, positive 2. And down here is negative infinity. Now this one is confusing because we did this one from top to bottom. But when I go to write my range, I need to go from bottom to top. So I need to start with negative infinity, comma, 2. If negative infinity is in your interval, it must be first. You cannot have a number, comma, negative infinity. You always have a number, comma, positive infinity. If you want infinity over here, it needs to be this one up here. This one up here, positive infinity, I'm going to write it very lightly, is not in this graph, so I cannot use it. Okay? Infinity, positive or negative, always has a parentheses, and since the 2 is closed, I'm going to put a bracket. All right, I'm going to go ahead and start with my curly brackets, y such that, because remember we're doing range. This time I want to know, is it the y's greater than 2 or smaller than 2? So this is where I'm going to use y and the number 2, not the infinity. And I'm just going to say, are these numbers smaller than 2 or bigger than 2? So pick one. Is -1 smaller than 2 or bigger than 2? Well, it's smaller. The 2 has the bracket, so or equal to, squiggle it up and you're done. All right, last graph, here we go. Remember, we're reading the y-axis. So I can see visually that here's where the graph starts. So I'm gonna pull it over to my y-axis. I'm noticing those arrows again, and it looks like that graph would just shoot up and never stop. This number down here is +1, and this number at the top is positive infinity. Now remember, you're reading your graph from the bottom to the top, the bottom to the top. So I must start my interval notation with the number 1, comma, positive infinity. I always read bottom to top when I read range. Plus, infinity, positive infinity cannot be first. Positive infinity must be second. Negative infinity is the only infinity that goes first. They have to be in those places. They cannot switch. It just doesn't work that way. Infinity, positive or negative, gets a parentheses. The 1 is closed, so I'm going to go ahead and give it a bracket. Start with my squiggle, y such that. This is where I put y and 1, and I'm going to decide, are these numbers in that blue highlight bigger than 1 or smaller than 1? I'm not quite sure, so I'm going to pick one. 2 is 2. Is 2 bigger than 1 or smaller than 1? Bigger. So I'm going to put equal or greater than. I want to put equal to because it is closed. There is no obvious opening to my graph. And I'm going to go ahead and finish with my squiggle. All right, when I'm done with the video, I'm going to go ahead and glue that into my notebook. Once again, if you guys would like this given to you, I'll go ahead and send that to you if you'd like. In the last example, we're going to talk about absolute and local maxima and minimum. So maxima is just like the biggest part, and that would be the absolute biggest part of the graph. And then the minimum would be the absolute minimum would be the very lowest. Now we're only talking about the x value here, or sorry, the y value. Yes, we're going to talk about only the y value. So we're going to look at the ordered pairs where we have the biggest and the smallest, and we just have to write the y value for it. So we're going to take a look at our graph. Let me kind of zoom in for you here so you can see it a little bit better. And the absolute biggest part of the graph that I see is this right here. Right there. There's my absolute max. So I'm just going to go ahead and write on my graph ABS for absolute, and I'm going to put MAX for maxima. And if I look at my graph again, I can see come down here and I can see this point being my ABS absolute, min, M-I-N, minima. Now, my graph makes a couple more bumps. It makes a bump right here, and it makes a bump right here. These would be considered local because they're not the highest or they're not the lowest. This one would be another minimum, and this one would be a maximum. Okay, so once again, they are ordered pairs, but when you identify them, you only need the y value to identify them. So my absolute max would be at 4, comma, it looks like 5. So my answer is 5. That's it. I don't have to worry about any kind of notation. Absolute minimum, it looks like 2, -6, 2, -6. That would be the ordered pair, right? Let me write that, 2, -6. And this one was 4, 5. but I only need the y value, so I'm only going to put -6. Okay. All right. Local maxima. So I'm going to come and look at this one, and it looks like the ordered pair -1, comma, +2. I only need the y value, 2. Now, there's some people that say, well, 5 is also a local maxima, but it's already been identified as the absolute, so there's really no need to identify it again. I probably wouldn't count it wrong for you. If you did. I'm going to go ahead and leave the local minimum blank for you. I want you to tell me in the warm-up for the next class period what the local minimum for this example would be. And what I am going to do to help you out is tell you that this ordered pair looks like -3, comma, -2. So you guys have to decide which one of those two numbers is the local minimum, and that's going to be your bell ringer for our next class. So I'm just going to go ahead here in my notes and write bell ringer / our warm-up. And I will see you guys next time. Bye.